Ever imagine like stepping into some futuristic machine,
Oh.
right? You punch in a date
Oh, yeah.
and whoosh, you're just transported
To another
to
time.
another time, witnessing, I don't know, the pyramids being built maybe,
Yeah.
or having tea with like a future version of yourself.
It's wild.
Time travel.
Yeah.
Like the stuff of dreams,
Oh, sure.
sci-fi movies,
Absolutely.
and maybe, just maybe,
yeah.
real science.
It's definitely one of those captivating ideas out there.
Right.
For sure.
And while, we haven't exactly cracked the code
Yeah.
to building, an actual working time machine, like
A working time machine.
the idea itself, it's not totally crazy.
No, not at all. It starts with Einstein, right? His theories of relativity. Those
Yeah.
are like the rule book for how time works.
That's so cool. Welcome to Cosmos in a Pine, our space and astronomy series.
Glad to be here.
Today, we're taking a deep dive into time travel.
Okay.
Is it pure fiction,
Yeah.
or could physics actually allow this?
So to really kind of wrap your head around time travel, think of time like a river, right?
Okay.
It's constantly flowing.
Yeah.
We experience it as this straight path,
Yeah.
but Einstein showed that it can be warped, it can be stretched,
Oh, wow.
almost like, a river bending around a mountain.
So instead of a rigid, clock,
Yeah,
time is more like this flexible, dynamic kind of thing.
exactly.
Huh.
Now, there are two basic types of time travel. Forward and backward.
Okay.
Traveling to the future, that actually has some scientific backing.
Really?
Whereas going back in time, that's much more speculative.
Okay.
And honestly, just full of paradoxes.
Paradoxes, yeah. Okay, so let's start with the future then.
Sure.
How can we possibly even travel, ahead in time?
So the key is this thing called time dilation.
Time dilation.
Yeah, which comes directly from Einstein's special relativity.
Okay.
Imagine you have two identical clocks.
Okay.
One stays here on Earth.
Okay.
The other one, we put it on a spaceship. And this spaceship travels at an incredibly high speed, close to the speed of light.
Okay, wow.
Now, when that spaceship gets back to Earth,
Yeah.
the clock that was on the spaceship is going to show less time has passed
What?
compared to the clock that stayed here.
So the clock on the spaceship literally traveled into the future.
In a way, yes.
Wow.
The faster you move through space,
Yeah.
the slower time passes for you relative to someone standing still.
Okay.
It's like taking a shortcut through time.
That's wild.
Right.
But haven't we actually, seen this happen?
We have.
Yeah.
So astronauts on the International Space Station,
Right.
because they're orbiting Earth at high speed,
Okay.
they actually age a tiny bit slower
Really?
than people on the ground.
Wow.
They're essentially time travelers, but just on a teeny tiny scale.
So, traveling to the future,
Yeah.
even if it's just a tiny bit, it's actually possible.
It is, theoretically.
Wow.
But to really make these big jumps into the future, we'd have to hit those speeds close to the speed of light,
Right.
which is a whole other
It's
challenge.
a whole other thing, right?
Right.
Okay, that's forward time travel.
Yeah.
What about going back in time?
Yeah.
Is that even remotely possible?
That's where things get really tricky,
Okay.
both scientifically and philosophically.
Okay.
Traveling to the past, it's just riddled with paradoxes. They
Yeah.
really make your head spin.
Yeah.
Imagine going back in time
Okay.
and you accidentally stop your parents from ever meeting.
Okay.
If they never met, you wouldn't exist.
Right.
So how could you have gone back in time in the first place?
That's like the classic grandfather paradox,
Right. The grandfather paradox.
It really makes your brain hurt a little bit.
It does. And there are other types of paradoxes too.
Oh, wow.
But even if we just put those aside for a moment, the physics of backward time travel,
Yeah.
it's much more speculative.
Okay, so are there any, actual scientific theories about how backward time travel might work?
There are,
Okay.
but they all have major caveats.
Oh.
One idea involves wormholes,
Wormholes.
these theoretical tunnels through space-time
Okay.
that could connect distant points in the universe.
So, shortcuts through the fabric of reality.
Exactly.
Wow.
Now, if one end of a wormhole were to experience really strong gravitational effects, like near a black hole,
Okay.
time would actually move slower at that end
What?
compared to the other.
Really?
And that difference in the flow of time,
Yeah.
that could, in theory, allow travel between different points in time.
So you could potentially, step into one end of a wormhole and come out the other end in a totally different time period.
That's the idea.
Wow.
But there's some big ifs involved.
Okay.
For one, we're not even sure wormholes actually exist.
Real.
They're purely theoretical at this point.
Okay.
And even if they do exist, they're thought to be unbelievably unstable. They would probably collapse before you could even get close.
So it's not as simple as, hopping into a cosmic subway.
Right.
and just, like, choosing your destination year.
Not quite.
That
There are other wild theories out there, too, like cosmic strings.
cosmic strings.
Yeah, these super dense wrinkles in the fabric of space-time,
Okay.
left over from the Big Bang.
Oh, wow.
They could potentially create what are called closed time-like curves.
Closed time-like curves.
Yeah, paths through space-time that loop back on themselves,
Well,
allowing for backward time travel.
so, like, wrinkles in the universe
Yeah.
that act as time machines.
That's one way to put it.
Wow.
Very simplified. But again,
Yeah.
the existence of cosmic strings is completely hypothetical.
Right.
And even if we found one, manipulating it to actually enable time travel,
Yeah.
that would be something else entirely.
Seems like every potential method, right? For backward time travel comes with a whole bunch of problems.
It does.
What about black holes? Don't they have something to do with time?
They do, specifically rotating black holes,
Okay.
known as Kerr black holes.
Curved black holes.
So they spin so rapidly,
Yeah.
they could potentially create a time loop
Okay.
around their singularity.
Oh, wow.
In theory, if you entered this loop, it might allow for backward time travel.
So you could, like, swirl around a black hole
Yeah,
and end up back in the past.
potentially.
Isn't that a bit risky?
Risky is an understatement.
Right.
The gravity near a black hole,
Yeah.
it would crush anything that got too close.
Okay.
And even if you survived,
Yeah.
there's no guarantee you could escape the loop or even control where you ended up in the past.
That sounds less like time travel and more like
Yeah.
a cosmic suicide mission.
Yeah, kinda.
Okay, are there any other theoretical methods that are a little less
Yeah.
extreme?
One more intriguing idea is this thing called the Tipler cylinder.
Tipler cylinder.
So it's a hypothetical, infinitely long,
Infinitely long.
spinning cylinder
Okay.
made of incredibly dense matter.
Okay.
Now, if you could build one of these
Yeah.
and spin it fast enough,
Okay.
it would warp space-time,
Right.
enough to potentially create a pathway for time travel.
An infinitely long cylinder.
Yeah,
That sounds
it's out there.
a bit ambitious, even for theoretical physics.
It really pushes the limits of what we can even imagine,
Yes.
let alone build.
Right.
And that's actually a common thread running through all these theoretical methods.
Totally.
They need stuff we've never even seen, like exotic matter with negative energy,
Right.
or technologies way beyond what we can do right now.
Right.
Like way beyond. Yeah. Yeah, we're talking about manipulating the very fabric of space-time.
Right.
A feat that would need just an unbelievable level of understanding and control of, like, the whole universe.
It does seem like the more we go into backward time travel,
Yeah.
the more questions we have.
Exactly. And some of those questions go way beyond just physics.
Really?
Yeah, they go into the realm of, like, philosophy.
Oh, wow.
For example, the whole concept of time travel makes us rethink the idea of causality.
Causality.
The notion that a cause always comes before an effect.
Okay.
Right.
So, like, the classic example.
Yeah,
A butterfly flaps its wings in Brazil,
right.
and it can eventually cause, like, a hurricane in Florida.
Precisely.
You mean-
But if we could travel back in time, wouldn't we be able to mess with that whole chain of cause and effect
Yeah.
and create all sorts of crazy consequences?
It's like time travel throws a wrench into the very order of the universe.
In a way, it does.
Wow.
It challenges our whole understanding of how time flows and how events actually happen.
Okay.
And that leads to another really interesting concept, the arrow of time.
The arrow of time.
Why does time seem to only move in one direction?
Right, from past to future.
Exactly. And this idea is really closely tied to this concept of entropy,
Entropy.
which basically says that disorder in the universe always increases.
So, like, if you drop a glass and it shatters into a million pieces,
Yeah.
it's not just going to suddenly reassemble itself.
Exactly.
Entropy, like, keeps things moving in one direction.
Exactly. But time travel, especially going back in time,
Ah,
seems
yeah.
to go against this whole principle.
Right.
If we could just move around freely in time,
Yeah.
wouldn't that, like, mess with the arrow of time and
Yeah.
create just absolute causal chaos?
And the time travel could just, like, unravel the fabric of reality.
Yeah. And that's a concern
Yeah.
many physicists and philosophers have thought about.
Right.
But there are some theories that try to reconcile time travel with this arrow of time.
Okay.
And one of the most fascinating ones
Yeah.
is this idea of the multiverse.
The multiverse.
So not just one universe,
Yeah.
but many.
Oh, wow.
Yeah, some theories suggest that time travel doesn't actually change the past in our own timeline.
Okay.
Instead, it makes a split.
Okay.
It creates this branching off point where a new parallel universe is born.
Really?
with a different version of those events.
So instead of like rewriting our own history,
Yeah.
we'd be creating completely new universes
Uh-huh.
with different timelines.
That's the idea. It's like having infinite parallel worlds,
Wow.
each with its own unique set of events happening.
Okay.
What we do in the past wouldn't erase our present,
Right.
but it would put us on a different path in this massive multiverse.
It's a pretty mind-boggling concept.
It is.
But it does seem to like address
Yeah.
some of those paradoxes we were talking about.
It does. The multiverse theory gives us a possible solution to the grandfather paradox.
Okay.
For instance, imagine you went back in time and you changed events
Yeah.
that led to you existing.
Right.
Well, you wouldn't be erasing yourself from that original timeline.
Right.
You'd just be moving to a different branch of the multiverse where you still exist.
It's like having this cosmic safety net
Right.
that makes sure that even the most crazy changes to the past don't completely like destroy reality.
In a way, yeah, the multiverse theory allows for more flexibility when it comes to time travel.
Okay.
It suggests that the results of changing the past might not be as bad as we think.
Okay.
It's a really awe-inspiring idea,
It is.
but it also shows us just how much we still don't know about the universe and what time really is.
Right.
Yeah.
Absolutely. Time travel really pushes us to the edge of what we understand.
It does.
It makes us face the limits of like our current models
Yeah.
and think about possibilities that just seem, completely fantastical.
Right.
So backward time travel,
Yeah.
it's still very much in the realm of speculation,
For sure.
but it does make us ask these like really deep questions
It does.
about reality, causality, and the limits of what we know.
Absolutely.
Speaking of understanding, can we shift gears a little bit?
Sure.
Let's talk about like the actual scientific research that's
Yeah.
being done
Yeah.
in relation to time travel.
Okay.
We've talked about the theories, but what about the evidence? You mean there are scientists out there actually studying time travel?
Yeah.
It's not just like theoretical physicists and sci-fi writers.
Right. So we haven't built any working time machines,
Okay.
but there are some real scientific observations
Okay.
that support the idea that time is a lot more flexible than we usually think.
Okay, I'm intrigued. Give me some like concrete examples.
Okay, so remember time dilation.
Yeah, the slowing down of time for things moving really fast.
Yeah, so that's not just a theory. It's been proven many times
Hi.
using atomic clocks.
So scientists have actually measured time dilation happening.
They have.
Huh.
For example, they've flown atomic clocks on airplanes and satellites.
Okay.
And they show a little difference in time
Okay.
compared to clocks that stayed on the ground.
Right.
The clocks that traveled at higher speeds show that a tiny bit less time has passed,
Wow.
exactly like Einstein's theories predicted.
So it's not just some hypothetical thing.
Yeah.
Time dilation is something we can measure.
It-
That's incredible.
And these measurements just prove that time isn't this fixed thing.
Right.
It's relative, it's affected by things like speed and gravity.
That brings us back to, Einstein and his like revolutionary theories.
Right.
Are there any other observations that support this idea of time being, malleable?
There are.
Okay.
We've also observed what's called gravitational time dilation,
Okay.
the slowing down of time in strong gravitational fields,
Right.
like the ones you'd find around massive objects such as black holes.
Wait, so time literally moves slower near a black hole?
That's right.
Wow.
Observations of stars orbiting close to black holes have actually confirmed this.
Really?
The intense gravity warps space-time so much
Yeah.
that time itself slows down near it.
It's almost like black holes are like these cosmic time machines,
Uh-huh.
distorting time around them.
In a way, yes.
Wow.
These observations not only strengthen our understanding of general relativity,
Okay.
but also provide more evidence that gravity can change the very nature of time.
It's like a glimpse into a world where time itself bends to the will of these huge objects.
It is.
It's mind-boggling.
It's mind-boggling, and as we keep exploring the cosmos,
Yes.
studying black holes and these other crazy environments,
Yeah.
we're bound to find even more mind-blowing stuff about the nature of time.
It's amazing to think that we've gone from these theoretical predictions
Yeah.
to actually seeing this stuff happening in the universe.
It is. It really shows the power of scientific exploration
Yeah.
and how our understanding of the cosmos keeps growing.
Right.
But it's not just about observing from afar.
Right.
Scientists are doing some cutting-edge experiments here on Earth, too.
Really?
Yeah, they're going into the quantum realm
Oh.
to search for clues about time and causality.
Quantum experiments. What do those have to do with time travel?
The quantum world is this strange and counterintuitive place
Okay.
where the rules of classical physics don't really apply.
Right.
And within that world, there
Yeah.
might be these hidden pathways, these mechanisms that could maybe let us manipulate time in ways we can't even imagine yet.
So we're talking about using the weirdness of quantum mechanics
Yeah.
to unlock the secrets of time travel.
In a way, yes.
Yeah.
Researchers are looking into things like quantum entanglement,
Quantum entanglement.
where two particles are linked
Yeah.
in such a way that they share the same fate,
Okay.
even when they're separated by huge distances.
It's like this spooky connection that goes beyond space and time.
Exactly.
Wow.
And while entanglement itself doesn't directly lead to time travel,
Right.
it does give us valuable insight
Okay.
into how interconnected the universe is
Okay.
and the strange ways information can be sent,
Yeah.
maybe even across time.
It's a reminder that the universe is full of mysteries we haven't figured out yet,
It is.
and that the search for time travel could lead us to discoveries
Yeah,
that completely change how we understand reality.
it could.
Wow.
It's a journey worth taking,
Yeah.
even if we don't know where it leads.
Right. Speaking of journeys, what about those massive experiments,
Yeah,
like the Large Hadron Collider?
right.
Does that play a role in understanding time travel?
It does. The Large Hadron Collider, or LHC,
Uh,
is the most powerful particle accelerator in the world.
wow.
It smashes atoms together at crazy speeds,
Okay.
recreating the conditions that existed just fractions of a second after the Big Bang.
It's like looking back to the very beginning of the universe.
It is.
Yeah.
And by studying the pieces from these collisions,
Yeah.
scientists are learning so much about the fundamental building blocks of matter
Okay.
and the forces that control the universe.
Right.
This knowledge could help us figure out how to manipulate space-time itself.
So by pushing the limits of energy and matter,
Yeah.
these experiments could show us new particles or things that shed light on, like the nature of space-time.
Exactly.
Oh.
The LHC and other advanced research facilities are tools for looking into the deepest mysteries of the universe, trying to find answers to some of the most profound questions about time, space, and our place in it all.
It's a truly awe-inspiring endeavor,
It is.
fueled by human curiosity and this desire to learn more.
Absolutely.
Okay, so after all of this,
Yeah.
where do we stand?
Right.
Is time travel actually possible?
Yeah.
Or is it just this really cool idea
Right.
that's always going to stay in science fiction?
Well, it kind of depends on what kind of time travel we're talking about
Okay.
when it comes to forward time travel.
Yeah, traveling to the future.
Yeah, I'd say it's a cautious yes.
A cautious yes.
We know time dilation is a real thing.
Right.
It's been proven. So
Yeah.
technically, traveling to the future is already happening in
yeah.
a way.
We talked about astronauts aging a little slower in space,
Right.
but to make those like really big jumps into the future,
Yeah.
wouldn't we have to go to like almost as fast as light?
That's the thing.
Right.
Getting to those speeds would take technology way beyond anything we have now.
Yeah.
We'd need completely new ways to, like, make energy and move through space.
Yeah.
And some serious protection from all the crazy forces involved.
Right.
It's a huge challenge, to say the least.
So while forward time travel might be based in physics,
Yeah.
it seems like those big jumps into the future,
Uh,
they're still in the world of sci-fi.
for now, at least, yeah.
Okay.
But the possibility is there.
Right.
Now, backward time travel?
Yeah.
That's a whole other story.
Right. We've talked about all the paradoxes,
Yeah.
the lack of like any real evidence,
Right.
and just how mind-blowing it all is going back in time.
Yeah.
Even a little bit possible, scientifically speaking.
It's highly speculative, to be honest.
Okay.
The challenges are enormous.
Yeah.
Those paradoxes, they make you wonder if backward time travel could ever make sense. And then there's the energy problem.
Yeah.
To mess with space-time that much.
Yeah.
You'd need a ridiculous amount of energy, like more than we can even imagine.
And we haven't even like talked about the actual problems of building a time machine,
Right.
assuming we even could.
Yeah, all those ideas we discussed, wormholes, cosmic strings, Tipler cylinders.
Right.
They all need things we've never actually seen, or technology that's way beyond what we can do.
Sounds like the idea of hopping in a time machine and going back to the past
Yeah,
is probably going to stay just that,
right.
an idea.
It might, but even if building a time machine turns out to be impossible,
Yeah.
just thinking about these ideas is valuable.
Okay.
It makes us think hard about time, cause, and effect,
Yeah.
and the limits of what we know.
Okay.
It pushes science forward and makes us use our imaginations.
It reminds us that there's still a lot about the universe
Oh, yeah,
that we just don't understand,
for sure.
and that we're not done discovering things.
Absolutely.
Who knows, maybe someday some genius will figure something out
Yeah,
that changes everything.
right.
Maybe there are these hidden laws of physics out there
Yeah.
that could make time travel real. It's both exciting and a little scary to think about.
It is.
But even if we never actually travel through time,
Yeah.
just trying to understand it
Mm-hmm.
has helped us learn more about the universe and where we fit in.
It's a testament to human curiosity and our need to explore the unknown.
Definitely. Well, that brings us to the end
Yeah.
of our deep dive into time travel.
It has been a journey.
It's been a really wild ride through physics, philosophy, and imagination.
We've looked at the possibilities, the challenges, and what it would all mean if we could actually control time.
And while we still don't know if we'll ever be able to time travel,
Right.
one thing's for sure,
What's that?
exploring these ideas keeps inspiring us
Yeah.
and making us wonder.
It does.
So as we wrap up,
Yeah.
we leave you with one last thought.
Okay.
If you could travel through time,
Yeah.
where would you go?
Right.
And what would you do with that power?
That's a great question.
It makes us think about not just the science,
Yeah.
but also the ethics and what it all means.
Absolutely.
Until we figure all that out,
Right.
the answer is up to our imagination.
Yeah.
And maybe a little bit of cosmic wonder.
A little bit.
Don't forget to follow and subscribe to Cosmos in a Pod and our YouTube channel.
Yes, please do.
Thanks for joining us on this amazing trip through the mysteries of time and space.